Good morning, kids. Today we are going to discuss the problem on SHM or oscillations. So here the problem is based on the phase difference between two particles. Let me read the question. Two bodies are executing SHM such that their amplitude is A and the time period is T. When one of the block is at right extreme and the block is at plus A by 2 moving towards left. Find the time at which both the blocks will have same position from equilibrium position. Okay, now fine. Here I have this is one particle, this other particle. Now particle 1, this is the mean position. This is the left extreme. Right extreme. This is the right extreme. So where is the particle 1? Particle 1 is here. Where is the particle 2? This is the position of particle 2. We'll just indicate like this. This is a 1. Huh? This is a 2. Fine. Okay, now we have to calculate the time taken. At t equals 0, they are here. What about the particle 1? Particle 1 will retrace path like this. Particle 2 will come like this somewhere here. And initial distance how much? This is a by 2. This is a by 2. Fine. And this is amplitude is a. This is the mean position. Okay, fine. Huh? So now, what about the particle? Particle 1 will start like this. Somewhere they'll meet here. They'll meet at common point here. This is a time is asking. So what about this distance? How much it will be? This distance, let it be x. Let this distance be x here. So here the particle 2 will be here and the particle 1 will be here. So this time is what you have to calculate. This is t equal to 0. After what time they will cross each other. So what about the particle? Particle 1 will start from right extreme, will cross mean, will be here. The particle 2 will have velocity towards left at a by 2, will cross mean position, will reach left extreme, then will come here. So they will cross each other. This time we have to calculate. Here it's having velocity, how much it is equal to v. It is having some velocity, initial velocity. This will be at instantaneous rest. How to solve such all problems? We have to solve all these things by using the phase angle, by using a circle. So let me draw the circle. I'll draw a better one. This is a circle. So how to, where the particle 1, these are some reference lines, I'm drawing it. Where the particle 1 is here. This is a 1. What about particle 2? Particle 2 is here. Let this be the. Now, at what distance it is? It is at the distance of a by 2. This is the this total amplitude is a. So first we'll calculate what is this angle, this phase angle needed for us. Now first we'll calculate the phase angle. So phase angle of this will be, so some theta I will call it. So what is sine theta equal to a by 2 by a. So theta will be pi by 6. What actually happens after some time, the particle 2 will be here and particle 1 will be here, and they will be on same horizontal line. So there's the meaning of they'll cross each other. So now we have to calculate this particular. This angle we don't know, we have to calculate this angle also. Okay, so this is the one, this is 2. So what is the basic idea of this one? Particle 1 will start from here at t equals 0, will reach here. Particle 2 at t equals 0 will start and will be here. So they are at same level. So he's asking now the time taken. So we'll indicate the time. Okay, this is the time t. They are here. This is t equal to 0. Okay, fine. Now, what is the angular displacement? If you look at the particle, one, how much of angular displacement it will undergo? Pi by 2 plus pi by 2 minus alpha, or pi minus alpha. So what is this angle? This angle will be pi minus alpha. The angular displacement of particle 1 will be phi 1 will use some other symbol, will be pi minus alpha. Then similarly, angular displacement of second particle. Second particle, how much of angular displacement it will undergo? It will start from here, pi by 6 theta, then pi by 2, then alpha. So this total angular displacement is needed. So this should become equal to pi by 6 plus pi by 2 plus alpha. Okay, this will be pi by 2 if you take it outside. We'll do one thing, we'll take the pi by 2 outside. So 2 pi by 3 plus alpha. Okay, now what time it will take? The omega will be same time period. So what is the given here? The time period is same. Means what time the 1 will take to move from here to here. The same time the 2 will take to move from here to here. So therefore, based on that, now, so what we can write here, the angular displacement phi 1 by t should be equal to phi 2 by t. So this should be equal to pi minus alpha should be equal to 2 pi by 3 plus alpha. So here what will cancel? The t will cancel out. The time should be same. The time will be same. this time and this time will be same, because same time period, no, here same time period t. So we'll solve for now the here pi minus 2 pi by 3 to alpha. So alpha will be, this will be 3 pi minus 2 pi will be pi by 3. So alpha will be pi by 6. Now we'll calculate the time. For one angular displacement, means like for one oscillation, what is the time it will take? Capital T. Then for this much of angular displacement, phi 1, what is the time taken? That is T. So therefore now what we'll write here is like a 2 pi by, for one oscillation it will take time T. Some issue is there with the, I'll write it properly. This will be for one oscillation 2 pi. Then for angular displacement of phi 1, what is the time it will take? So we'll substitute the values. So 2 pi by capital T. 2 pi by capital T is equal to, this will be 2 pi by 3 plus alpha alpha is how much? Pi by 6. I have to further simplify this. This will be 2 pi by capital T. Oh, I think some software is the issue. So total pi will get eliminated. So 2 by 3 plus this will be 2 by T. 3 if you take common, 5 by 6. So time will be 5T by 12. This will be your answer. Okay, fine. So this idea of drawing circle, like drawing a phasor diagram is something very important. This is called like a phasor diagram. So whenever you are comparing either time taken for one particle or time taken for two particles, this taking help of circle, and there's a basic next one more important idea. For one oscillation, time taken is, for one oscillation, the angular displacement 2 pi, the time period will be T. For angular displacement of phi 1, then what is the time taken? I think these are some very important things are there. So you have to take help of these things. Okay, kids, we'll take the next problem. Thank you all of you. Thanks for great support.